is your 1% question. In a room of 100 people, 99% are left-handed. How many left-handed people have to leave the room to bring that percentage down to 98%? And your 30 seconds starts now.
Okay, so yeah, this is a very simple question, and I'll try to answer it in two ways if I can. But then I think it's just very basic. In a room of 100 people, 99% are left-handed. In other words, 1% is right-handed. So because we are looking at left-handed and right-handed persons now. So 98% are left-handed. Okay, let's not conclude, but whatever is remaining is 1%. It could be right-handed people, it could be ambidextrous people. So, but just say 99% are left-handed. So the remaining 1% is not left-handed. That's what we are going to say. So I think I'm going to conclude that that person is right-handed for this. Okay. So how many left-handed people need to leave the room to bring the percentage down to 98%? It's safe to say that if there are 99 out of 100 people, which is a percentage that is left-handed, and 99 people are left-handed and one person is right-handed. Okay, but then since the left-handed people are the ones we are reducing, the right-handed person is not leaving the room, which makes it a constant person. So a constant information. So we are going to leave it there, because that's what is going to help us form this quick equation that we want to do now. Okay, so to create the new percentage which is required of us, we're just going to come here and say I'm using L for the left-handed person. So we want to create a fraction because percentages are fractions, right? We're going to say the left-handed persons, which is remaining, okay, all over the left-handed persons plus 1, which is the total. The left-handed persons plus 1 is representing the right-handed person. So the left-handed person out of the total should be 98%. That's just our math statement. Should be 98%. I could write 98%, but I want to write it as a fraction. So I'll just write 98 over 100 like this. And if we are able to solve this, we are going to get the number of left-handed persons that could make 98% from this. Okay, and once we're able to get the number of left-handed persons, initially we know that they were 99. It's just easy to go ahead and subtract. The first thing we can do here is multiply both sides by 100. This 100 is going to terminate this one, so it's going, and this is going to multiply this one, making it 100 L. We are done with the first stage. The next thing is we move the whole of the denominator to be multiplied by both sides. Yeah. Okay, so of course this denominator is going with this one. And we are going to open up this bracket by distribution. So we have 98 times L is 98L. 98 times 1 is 98. Okay, so we are collecting like terms. This 98 is going over to the other side. Okay, 98 minus 98 here gives us 0. And here it should give us 2L. Then we are going to divide both sides by 2. And the number of left-handed persons should be 49 that is remaining. So from 99 we had 49 persons. So we could conclude that the difference between the left-handed persons, so I'll just say DL is equal to 100 is equal to what now? The L should be the difference between the left-handed persons. Should be initially they were 99 and they are going to be 49 now. And when we check DL, what is DL? The difference between the left-handed persons, that should give us 50 persons. So 50 persons are supposed to leave for 8 to bring it down to 98%. So this is one easy way to do it. But when I saw the question, what came into my mind was, because I was able to solve this in a space of 5 minutes, 5 seconds precisely. What came into my mind was this. Let's say we have 99%, right? That would be 99 over 100. So I'm going to write this as a fraction because working with a fraction is better for me than working with decimals. Though I do work with decimals sometimes, but I prefer working with fractions, percentages as fractions. Okay, very good. So what came to my mind is, okay, so we need a difference of 1 always. So what amount am I going to reduce this so that I'll have 98%, but I'll have a difference of 1? And what just came into my mind is, let's get this to 98 first. When we want to get this to 98, I'm just going to claim that I'm fixing a mistake. So I'm getting this to 98. Okay. Yeah, I'm okay with that. Like this, we have a difference of 2. But what we don't notice is that we can actually reduce this to lowest term. So that is it. 49 over 50. And it's a difference of 1 because 50 minus 49 is 1, which is that one right-handed percent. So if it moved from 99 to 49, that means there is a difference of 50%. And I checked that if you take away 50 from the left-handed persons and take away 50 from the total persons, because if the left-handed persons left the group, then it's generally 50% that left, or 50 people that left the group. So the total number of the persons should reduce by 50. And it was making sense. So 49 over 50 is empty as 98%, which is 49 left-handed persons and 1 right-handed person, because the right-handed person did not leave. So basically, I think this is a very basic math, very simple. It's just about listening to what the presenter was saying. If you said 1, you're wrong. If you said 2, you're also wrong. Okay, this is the correct answer. 50 left-handed persons have to leave.